Hello everyone, welcome back to the cutting edge stage here at Cognition X, or rather here online, wherever you're dialing in from at CogX. The next session I'm really excited about, which I'm sure you guys are too now that you're here ready to watch. It's all around exponential technologies for planetary health. And I'm actually just going to pass straight on to the moderator of the discussion, which today is Libby Kinsey. Please join me in welcoming Libby to your screen.
Good afternoon, and thank you so much for joining us for this session. My name's Libby Kinsey. I'm an independent researcher and consultant in machine learning, and also technologist at Digital Catapult. This session is about the potential for exponential technologies, and I guess really machine learning to be impactful in big problems for climate change and the environment. Our two speakers are going to describe how they are turning potential to reality by applying machine learning to specific problems in climate change mitigation and adaptation. We'll then move on to do a discussion about the use of machine learning in these areas, what works, what doesn't, the challenges, and how to get involved. This session is for you. If you are a machine learning specialist who you're motivated to put your expertise to use, but not quite sure how to do this, or if you're wondering what's hype and what's not, or if you're interested in how to move from problem identification to reality. So what are the special challenges for building teams, for funding, collaborating and deploying in this area? With no further ado, let's get started. Jack Kelly is co-founder of Open Climate Fix. Over to you, Jack.
Thank you very much, Libby. Hello, everyone. As Libby said, I'm Jack Kelly, co-founder of Open Climate Fix, and I'd like to talk to you a bit about my non-profit, Open Climate Fix, and about using machine learning to try and help balance the electricity system. So I'm sure I don't need to go through this slide for this audience, but just to really ram home this point, we have to reduce emissions really, really rapidly in order to keep warming to below 1.5 degrees C. So at the top of this graph, you can see we currently emit about 40 gigatons, or about 40 billion tons of CO2 per year. And we need to get that down to about net zero by about 2040. So in 20 years, we need to reduce emissions from 40 billion tons a year to about net zero. And that is a huge task, and we need to move very quickly. There's no time to waste. As this graph shows, the later we start reducing, the more rapidly we need to reduce emissions, because what matters here is the total stock of CO2 in the atmosphere, which here is the area under the curve. So the later we leave it, the more rapidly we need to reduce emissions. So yes, we must move quickly, and we must focus on solutions which the climate cares about. There are lots of things out there which are easy to talk about, which get lots of retweets and get lots of press coverage, but the climate ultimately doesn't care. So we need to stay laser focused on interventions that the climate will care about, where there's really sizable emissions reductions. So in Open Climate Fix, we certainly can't claim to be doing anything more than just taking a very small part of this problem and trying to help. But the problem that we're focused on is described in this picture. So on the one hand, we have the energy industry on the left, and on the other hand, we have researchers. Many of these researchers would love to help the energy industry to reduce emissions, and many people in the energy industry would love researchers to help. But there is this enormous mountain of pain between the energy industry and researchers. So to be concrete, that's things like it's very hard to get access to data. It's very hard to know which problems industry really cares about. It's hard for researchers to test those ideas out in the energy industry. And in Open Climate Fix, we're trying to help there. So yes, there's evidence there might be of the order of thousands of researchers who want to help reduce emissions, but they can't because, like we said, can't get the data, can't test it in the real world, and don't know which problems to solve. And this, of course, is both a terrible waste of talent and is also a terrible waste of an opportunity to reduce emissions quickly. So ultimately, what we want to help with in Open Climate Fix is to drill a hole through this mountain of pain and help the energy industry and researchers to talk together and to work on solutions rapidly. So our model is a completely open model. We're a non-profit. And so what we want to help with is, first of all, identifying a problem that industry cares about, releasing data and problem specifications and tools, hopefully engage many researchers to develop solutions, facilitate building industry-ready, open source, minimal viable products. It's building things that industry cares about, and so we can test these things in industry. And then we very much want other companies to take that code, take that research, and implement it for themselves. Better open up energy data. And the second is using machine learning to help forecast solar electricity power generation. And both of these projects ultimately are trying to help balance the electricity grid. So let me spend a few minutes just talking about balancing the electricity grid. So on your screens now, you can see a picture of the UK National Grid Electricity System Operator Control Room. And in a sense, these guys have a very clear task, which is balancing electricity supply and demand moment by moment. So the physics of the grid dictate that at every moment, supply must exactly match demand. And at the moment, it's hard to store significant quantities of electricity. And it also turns out that many of our generators take hours to spin up from cold. So we need to be able to forecast demand and renewable supply ahead of time. And ultimately, what these folks are, one of their main tasks is making sure that there's enough headroom at on the system at any moment to mean that automated systems can then modulate supply and demand within that headroom. So in particular, they will make sure that there's enough spinning reserve, which is just spinning generators like the gas turbine you can see on this slide. And these will be deliberately throttled back. So instead of operating at their max capacity, they might be operating at 50% of their capacity. And in that state, they can ramp up really quickly and help fill in any gaps in generation. So for example, if it's a sunny day and we have lots of solar electricity generation and a large cloud comes along and wipes out a gigawatt of solar electricity generation, then that generation needs to be replaced very, very rapidly by this spinning reserve. So if we had better forecasts for electricity supply from these renewable sources like solar electricity generation, then we might need less spinning reserve. And crucially, these generators are a lot less fuel efficient when they are operating at, say, 50%. So it would be better to have a smaller number of generators running at near to max capacity than a large number of generators operating throttled back. So I'm going to briefly talk about our main project at the moment, which is using machine learning to help forecast solar electricity generation. So we believe that better solar electricity forecasts should reduce costs and carbon emissions, primarily by reducing the amount of spinning reserve that we need on the system. But there are other mechanisms by which better solar forecasts might help reduce emissions. And this video on your screens at the moment shows two of the main data sets that we're working with. So there's satellite imagery. This is from a geostationary satellite, which takes an image every 5 minutes to the same point on the planet. And that's showing us clouds. And then overlaid on top of that are these circles, and each circle represents one solar electricity system in the UK. And the color of the circle represents the amount of electricity that system is generating. And you can see something that isn't particularly surprising, which is that when clouds move over a solar panel, it reduces its electricity output. And our task in trying to forecast this is effectively like pressing pause on this video at a particular time point, and then using machine learning and weather predictions to try and predict what's going to happen both to the clouds and the solar electricity generation over the next few hours. And we hope that people like the electricity system operators will find this useful to help them reduce spinning reserve and so to reduce emissions. So how do we forecast solar electricity generation? So there's really two main tasks, and then we combine those two tasks. So the first task is around nowcasting the amount of electricity generation for any location. So where nowcast is a slightly peculiar term, which just means forecast for the next few hours. And so the way that we are investigating to do this is we want to train machine learning systems on many years of satellite imagery and numerical weather predictions to basically learn the atmospheric physics that are relevant for understanding how much sunlight can move through the atmosphere. So that's one part of it. And another part is, of course, trying to predict the movement of clouds. And you can do that fairly well just by looking at the wind speed and direction for each pixel of cloud, and then moving that pixel of cloud according to that wind speed and direction. And that works fairly well for very short time horizon forecasts. But to go much further than that, you really need to learn the evolution of clouds, the way that they grow and shrink, the way that they condense from water vapor into little droplets of water or ice, and the way they evaporate away into nothing. That's part of what we're doing. Another part is just figuring out where all the solar systems are. So just drawing a map of where all the existing PV capacity is, where PV is photovoltaic. And this is perhaps surprising to folks that aren't intimately related to this field. Most people probably think that we already know where the capacity is. And there are some data sets which claim to tell us where the PV systems are, but there are pretty big gaps in these data sets. So we need to do a better job of both merging existing data sets and also of using computer vision on satellite imagery and the wisdom of the crowd and that sort of thing to try and map more of these PV systems. And for example, we've been doing projects with OpenStreetMap on trying to map the location of these PV systems. So once you have both, once you have a map, and once you know where, you know how much sunlight is going to fall on each bit of the Earth in the next few hours, you can combine these to forecast power generation. And so to just give one really concrete example of a machine learning project that we're doing, here what we're trying to do is just learn a mapping from satellite imagery to PV yield, where PV yield is just the output in kilowatts divided by the max output. So you get a value between 0 and 1. So here we're not interested in forecasting the future. We're just interested at taking a satellite image at, say, midday and inferring what the PV yield would be for a specific PV system at midday. And here, unsurprisingly, we're using convolutional neural nets that take a rectangle of satellite imagery and predict the PV output for a single PV system. And here are some very early results. So if we look at the top subplot, so on the x-axis is time in 5-minute increments. Sorry about the slightly ugly x-axis. And on the y-axis is PV yield from 0 to 1. And in orange is the ground truth, the actual PV output. And in blue is the inferred PV output from our neural net. And you can see at this 5-minute interval, it does a reasonably good job, but it fails to get these very high frequency changes, which we think are due to small clouds moving across. But if we take a rolling average, so here's an hourly rolling mean, we get a much better match, although sometimes it still goes a bit skew if, and we're investigating why. So this is just the very first step. There's loads to be done to improve performance, loads to be done to try and predict the future and use numerical weather predictions, but we're moving in that direction. And we hope to have a kind of minimal viable product of a solar forecasting API in the public domain, maybe by the end of the year, but please don't hold me to that too much. Cool, and I will finish there and hand back to Libby. Thank you very much.
Thank you very much, Jack. Next presentation is from Iggy Bassi, who is CEO and founder of Cervest. But before handing over to him, there's a short animation.
We all know the climate is changing, but who knows what that will mean for me, or you, for businesses, or communities. Cervest is creating Earth Science AI to enable decisions that protect our assets, including the one we all share. Our pioneering platform gives decision makers personalized, real-time insight into climate risk to their specific assets, increasing their resilience. Here's how. You've got an asset. Like all assets, it's vulnerable to climate volatility. Until now, to calculate risk, you'd have to review huge quantities of data, mostly historic, siloed, and none of it specific to you. Earth Science AI harmonizes vast and disparate data sources, interpreted by leading-edge machine learning, with best-in-class scientific modeling. For the first time, you can locate your exact asset, monitor it for climate signals in real time, and anticipate short-term shocks and long-range change. Soon, you'll be able to determine science-based risk ratings for disclosure compliance. Insights are shareable with stakeholders, and decision makers with multiple assets can build a complete understanding of their portfolio. At the heart of our mission is the democratization and transparency of climate risk to global assets. We don't have much time. We need better decisions now, and believe in the power of the tools we're building to help that happen fast.
So thank you very much, Libby, and also Jack. So just want to spend a few minutes talking about Cervest. So if somebody could just load up the presentation for me, that'd be great. Take it to the first page. Just going to walk through just a handful of slides just to give you some flavor of some of the work that we're doing and also the problem around data that we also find as well. So if you could just go to the next slide. I think Jack is right. We've had about 10,000 years of fairly stable climate. I think what we've seen the last 100 years or so is just a puncturing of that order. So I think the heart of the problem that we spend our machine learning time on is say, how do we deal with this volatility? Volatility is rising everywhere. It's becoming far more expensive. And that has a major impact in terms of how do we think about generating returns, whether they're economic returns, social returns, and also how do we think about ecological returns over time. So if you look at the world's assets, we have about $1 trillion worth of assets which are considered at risk just by the largest 500 companies. We're seeing about 100 million climate refugees by 2050 because of climate and resource conflicts. About 50% of the world's population will be living in very water resource stressed areas by 2025. So with all this rising volatility, what we can't quite figure out is with all the world's data, how can we make more sense of that data? If you just go to the next slide. So our work over the last 3 or 4 years has just found this massive gap between the awareness of the climate problem and how do people take everyday action into their decisions? And there are 3 primary reasons why people get stuck. The first one, as sort of Jack said, is data. Where we don't, even though we have lots of data, we have lots of the same data in the world, and we have a lack of what we call labeled data. And also, when you're thinking about the climate problem, you're fusing together probably a dozen different sciences together. So when you're asking large corporates or governments or everyday citizens to think about climate change, it's remarkably difficult for people to translate all this complex science, complex data. It's deeply fragmented. So people find that they're just not able to take the action that they want. I mean, there's some very easy wins that companies have taken around decarbonization, thinking about emissions. But in terms of climate volatility, we still find that even the most well-capitalized companies on Earth are not really thinking about the action that's going to drive long-term change, systemic change. How do they build more resilient assets? I think a second big area is there are no standards. Nobody quite knows how to measure climate risk. If you're looking at an asset in Argentina, if you're looking at a forestry in France, if you're looking at a nuclear plant in the USA, we haven't quite figured out a standardized methodology for the world. We are remarkably good at measuring so many things, but climate risk and climate volatility on a standardized basis is very difficult, which makes it very difficult for capital markets, insurance companies to think about, well, how do I assess one asset against another asset? How do I compare and contrast different risk profiles? I think the second area is largely around people's belief system. People have a horrible tendency to believe it's not going to happen to them. For many people, the climate problem is a psychologically distant problem. It's not something that's around the corner until it happens, of course, right? So, and some of that's just driven by climate denial, belief systems. So when we started this journey about 4 years ago, I had just sold a fairly large agribusiness that I had set up. I said, how can we figure out this complexity around data? How do we make a standard approach? But then how do we get people to really change their minds? If you just go to the next slide. One term that I found very problematic in the marketplace was actually just the term climate change. People have very strong emotions to this term, again, driven by their belief systems. So we framed the problem as a climate security problem. Ultimately, all these assets that generate our returns, our livelihoods, our ecological security, our social security, we should start classifying climate security as the primary problem. And people have different incentives. People think and they respond cognitively differently to their assets, their economic livelihood, their food security, for instance. So we've started using this term now with some early clients, and it seems to be working very well. It's actually changed the way people think about it because there's a visceral sense around people's assets rather than the psychological distance of climate change in the future. Next slide. So what we try to do to say that most of the world's science sits at a very high level, whether that's at a temporal resolution, a spatial resolution, and most of these climate sciences tend to operate at very different uncertainties, very different scales. So we've been trying to figure out how do we use machine learning, AI, statistical analysis over the last couple of years to bring all this together in a way that you can actually make decisions on your assets on a personalized basis. Now that sounds rather grand, but there are three areas that we bring it together. One is machine learning, particularly to the use of Bayesian statistics, data engineering, and physical sciences. And we call it Earth Science AI. And through that, we bring the world's assets. So we try and gather as many assets as possible because there is no label data. So we have to classify quite a few assets by ourselves. And then we bring lots of the world's scientific outputs. What we don't do is generate brand new science. Most of the world's physics is well understood. It's just deeply fragmented in multiple different sciences, and it's never been brought together in a way that can support everyday climate decisions. If you just go to the next slide, so that Earth Science AI feeds into the world's assets. So by classifying all the world's assets, we can start automatically identifying assets and downscaling that automated climate science to start quantifying and standardizing climate risk. And there are several things that we look at. We first look at just your historic risk. We just baseline your risk first. I mean, we are often surprised at how many companies in the world do not actually know their historic position on risk. They don't know which lever has gone up, which one has stabilized, which one has gone down, which one is accelerating. So in many ways, most of the world's assets, the first thing that we can do with our platform is just get large governments, companies, large communities to start thinking about what's already my situation, what's my scorecard today, what's my baseline, before we start thinking about forecasting. Now we are moving towards forecasting from an hourly basis to a decadal basis because every decision has a different time dimension. There are some people who need to make instant decisions. There are other decision categories that require multiple decades worth of forecasting. If you're going to build some of the power facilities that Jack was showing, for instance, you need to know what's going to happen in the next 30, 40 years. So to what degree of certainty can you bring if you're going to support a $500 million loan package, for instance? Then ultimately we get down to simulations. What happens if temperatures rise faster? If water changes suddenly, if the solar radiation patterns change, if cloud formations change massively, what's going to happen to the underlying assets that generate our livelihoods, our ecological returns? We have slowly started building up over the last 3 or 4 a large global inventory of assets, and these are built environment assets, everything from power plants to buildings, schools, hospitals, forestry, everything to rural assets, which are fields, agricultural fields, forestry, and river. To date, we have just over 500 million assets, which have largely been classified through machine learning algorithms. So we can bring all those onto a centralized platform. Just go to the next slide. Then all this feeds onto a centralized digital platform, and people can then generate that data into an API. But then, what we ultimately want is for people not to say, well, we didn't know about climate risk. We don't know how to make a climate decision. We're saying, you can start integrating climate risk into your everyday decisions, whether they are credit decisions, they're short-term decisions in terms of supply chain, insurance pricing, everything through to long-term, my decarbonization investments, my M&As, my capital expenditures, where do I put the next factory, for instance, right? Over time, we fundamentally believe this platform should be open. And I think it's only by giving the world this type of data at an asset level on a real-time basis that people can start beginning to make more climate smart decisions. Ultimately, it has to be an independent platform, and it has to be shareable. And that's what we are trying to build. If you just go to the next page. I think there's been a lot of push in the last 10 years for people to start disclosing. But again, I think just quantifying your climate and your carbon and your emission output isn't enough. So we'd like to use the power of digital technology with the power of ML to make assets simple. So you can extract your assets from a digital platform and start monitoring your historic, forward risk, and your simulations. Now, there will come a time when this type of climate literacy will have to be so obvious and so seamless into everyday decisions. So people like insurance companies and credit companies and government regulators will be able to understand and assess all your portfolio of assets on anywhere on Earth, and they can look at different timescales, they can look at different scenarios. Because in the next 4 or 5 years, if we continue suffering from the climate losses, which are now running into $200 to $300 billion every year in terms of insurance payouts, there will come a time when insurance companies will not fund businesses. They'll say, the risk has simply become too large. We can't quantify this risk, or we can't even tell you how to adapt to a different climate world. So part of the learning here is to say, how can I, climate-proof my asset over time? What best adaptations can I make over time over my asset? Next, and I'll wrap up fairly soon. We're on a fairly simple mission. We want to empower everyone to make the best possible decisions through our Earth Science AI. I think I've been working in climate for about 10 years. The excuse that I hate most is we just don't have the tools. We just don't know how to do it, or the science is too complex, right? So we've spent the last 4 years trying to debunk the science in a way that makes it as easy. Take all that climate complexity and turn it into a very simple service for you. Next page. We're a very small team in London. Just on the next slide, please. We're a small team of 30 people. We've done a bunch of work for some very large companies, testing and showing them the power of early detection on some climatic events, weather events, working with some interesting partners, and been on a bunch of interesting programs. Just in the interest of time, I'll just wrap up there. Just one more slide I have. And we need to think about this slide here. So maybe, Libby, you can think about some questions around, well, COVID has hit us, recession's hitting us, but the big wave of climate is just behind it. Thank you very much.
I will do. Thank you very much indeed, Iggy. So if we could have Jack back as well, we'll move on now to the discussion part. And what struck me about both of your presentations, which was by design, so obviously the case, was that you're both have been very concrete and careful in applying machine learning to climate change problems. And I just wanted to try and get this question of techno-solutionism out of the way, because that's a charge that is made against enthusiasts in machine learning that are motivated to get involved, but perhaps don't know which problems to best use their skills. What is an appropriate problem in climate for machine learning to be at least part of the solution, and how do you go about identifying one? Jack. both large and take a breath.
Big question, Libby.
Yeah.
I like to start as I mean to go on, Iggy.
Yeah, small. So yes, first of all, I completely take the point that we mustn't be overly focused on technical solutions. Clearly, to achieve the kind of carbon emission reductions that are required, we also need behavior change. We need to use less stuff, fly less, that sort of thing. And I guess the main reason that I'm working on tech and not behavior change is because I have no idea how to alter behavior. And I have tried briefly, and it just looks it looks very, very difficult. So I think my aim is to work on tech that might help reduce emissions in the relatively near term, to give people that are much smarter than me time to figure out how to change behavior. Now, I haven't answered your question yet. How to figure out which things to work on. I think it's really, really hard to come up with a hard and fast rule without diving really, really deep into the domain. So to be specific about that, I think it's very hard to, ahead of time, predict the carbon emissions reductions that you should expect from a particular technological innovation, because you need to consider all sorts of things, not just the direct effect, but also if there's going to be rebounds. So for example, one of the challenges with increasing energy efficiency is that the economic incentives are such that if you tell a factory owner, hey, you can produce the same amount of stuff for less input, then they'll turn around and say, great, I want to produce more stuff for the same amount of input. So that's probably a climate loss. It's hard to see that's a climate win. So yes, that's a long rambling way to say, I don't know. It's really hard. You tell me, Libby.
Well, I guess I was hoping you might point us towards domains in which there's large amounts of data, for instance.
Yeah.
Iggy, do you have anything to add to that question?
Yeah. So first of all, I fundamentally believe that technology in and of itself is not going to solve this problem. So everything that we do is designed to augment human decisions. But we do also need to recognize that human decision-making capability is not enough to look at the problems that we're actually facing. So I think that the climate problem is so large and so complex and changing in ways that, past history and past data doesn't always have the predictive power to look forward. So in many ways, we do need to augment technology. We need to understand, what are the limits of sort of human judgment, human decision making. I think there is an ethical dimension to the work that we do as well, and also what other work that other people should be doing is to think through the role of ethics. So the very first paper that we publish as a team is to say there's going to be a lot of uses and misuses of climate data, climate intelligence. How do we think about an ethical framework for that data? I think it's really important we understand that it doesn't matter what new technology comes to the market, whether it's climate intelligence or fintech technology, there's always going to be people who are going to game the system, right? And we have to be super careful about that. And how do we think about, open data committees? I think people don't like black boxes. I think that's what we've learned over the last couple of years as well. A lot of AI companies, the first wave of AI, ML companies, where they created too many proprietary technologies, which were just too hidden. People didn't quite understand the algorithms, the data collection methodologies. I think there's a big pushback against just pure black boxes. People like explainable AI. And this becomes important in the climate realm, where we're really asking the public purse to finance lots of the decarbonization, the taxes, right? So I think proprietary methodologies are probably not going to work so well.
Thank you, Iggy. You've touched on a few things that I want to get into. And one of them is you've both mentioned that, and at least I think one of the things we've just agreed on is that machine learning is never the whole answer. And so you're working with both inside existing systems and with different domain expertise in each of your companies. I suspect that has challenges of its own in terms of how do you translate between different domains. Is that something you found? And if so, what are good ways to address those challenges? And I'm going to go to Iggy just to be fair this time.
So again, on day one, we realized that this is a problem that requires multiple experts. There's not a single team that can solve this problem. So on day one, we started working with some of the universities because they have different approaches to sort of modeling. They have different data sets that we can use. We're actually, from a product design point of view and from an ML problem point of view, bringing teams together from different disciplines early is really useful, because we have some brilliant statistical scientists, but they need to be able to understand what is the market really asking? How do people actually make decisions at the end of the day? So, because perfect models then have to map onto perfect decisions, and that really doesn't happen unless you bring the different disciplines together early. So we have different approaches. We have an awesome head of product and a CTO. He's been able to mix the teams together in such a way that really forced the curve of the ML modelers, the data scientists, and also the people who are facing the market every day. Because there are no perfect teams for this type of stuff.
Jack?
Totally agree with all of that. Yeah, absolutely spot on. So in general, I think domain expertise is extremely important in solving many of these problems, and that problems need to be, or we need to focus on problems that users care about, that the industry cares about. So there's kind of wicked combination of, we've got to build solutions that are genuinely useful and that industry makes their lives easier, whilst also reducing emissions and whilst also hopefully reducing costs. And indeed, one of the main motivations behind making Open Climate Fix a non-profit and doing everything openly is exactly so we can engage with as many domain experts as possible. I think our view is that machine learning is a great tool, but it is just a tool that's useful for solving problems. And in some ways, a real priority is figuring out the right problems to solve. And that has to be done in collaboration with domain experts and users. And often it's important to distinguish between users and the people that are actually going to commission a piece of work. So that's also a challenge.
I think it's fairly unique within the sort of climate space as well, because it's a political choice. The rate of decarbonization, the taxes, the carbon tax and the carbon pricing, these are fundamentally political choices. So it doesn't matter how good the ML modeling, the outcomes are, the predictive capability, ultimately it comes down to political choices. I mean, Paris is great, but Paris is also non-binding, right? We haven't seen that commitment level yet at a political level. These will remain political choices, I'm afraid.
So let's stick with this theme a little bit. Jack's just mentioned that Open Climate Fix is not a for-profit company. I think, Iggy, that Cervest is a for-profit company, or perhaps a B Corp.
It's a B Corp too.
Okay.
Yeah. So our model is to say, let's have a freemium model where everybody could benefit from climate intelligence to a certain level in terms of resolution, temporal range of the actual forecasting. Because I've had the opportunity to work in Africa, Latin America, Europe. If we don't democratize this data in a way that's affordable and some level free, I'm afraid we're going to create this climate apartheid where some people who can afford the data, the rest data, will just privatize their data and optimize around their assets. But climate doesn't get solved on that basis. Fundamentally, everybody needs to raise the bar, right? So we make our platform as open as possible. There are obviously premium services. do need to pay the bills one day. So we need to operate in a way that makes the business sustainable over time.
I think this is almost a nub of the problem, is it not? As Jack was saying, that maybe the commissioners of work are not the same people who are beneficiaries, or there may not be very much overlap. And trying to build a company, whether for profit or not, does require funding of some sort. I wondered if you could talk about how you are funded and how that might be different to traditional venture capital, or maybe the same, and what are the challenges there?
Sure. Fundamentally, I think capital needs to be mission aligned. We do have a strong mission. So I was very purposeful with the capital that we brought in. So I brought in, first of all, angel investors who were very committed to this mission. I was very fortunate enough last year to meet 2 European VC funds who also believed in how do we use technology to solve big problems at scale. So they've come on board now. We're just doing a financing round now. Again, existing investors have supported us. I think they understand the problem we're trying to solve and the approach that we're trying to take it. It's not easy, right? Because you are trying to create a brand new category called climate intelligence. Jack's doing exactly the same thing. Trying to get people to think differently. When we go to large companies, we don't ask for the climate risk department. They don't exist, right? So suddenly you have to create this narrative to say, this is a big problem. There are brand new tools that you've never used before. This is how you use these tools. It takes time. And on top of that, you have a lot of uncertainty on the science. Science changes all the time. Different data sets come along. So you need a very rigorous scientific methodology. Then you have to productize that and then convince people to finance that. So it's really patient capital that you're looking for. Ultimately, it does require scalable capital. So we are looking for US investors for the next round of financing as well next year.
Jack, you haven't taken venture as far as I'm aware. How are you funding yourself?
That's right. So we are a company limited by guarantee. So we have no shares. So there's nothing for VCs to engage with. So we are funded at the moment by a grant from the European Space Agency to look into solar nowcasting, and another grant from Innovate UK to look at opening up energy data. And to the sort of looking to next year, we're keen to raise more funding, both grant funding, but also as we build out our solar forecasting tool, we want ultimately that to be financially sustainable. So the idea is that the code will be completely free, all the research will be completely open, but we will run a service, an API, and we'll try and make as much of that as cheap as possible, but we will charge for some of that to bring in some revenue. But one of the interesting things about solar nowcasting is, looks like we're pretty confident that it will reduce emissions, and we're pretty confident that it's not going to make billions. So it feels like quite a good thing for a non-profit to be working on, where it's something that's socially useful but won't bring in the returns that a VC would expect. And very briefly, that's partially because of this misalignment between saving money for the energy system and being able to bring in some of that reduced cost. So, for example, in the UK, we spend about £500 million a year balancing the electricity system. We think we can probably help reduce that by a reasonably large amount, but those costs are paid by the end users, not by the decision makers, and so it's hard to capture any of that value.
So I guess there are other issues as well, aren't there, with this disconnect or conflict between who the beneficiaries and the commissioners are, and I've lost my train of thought. I'm looking at the sidebar. What was I going to say? So this was about not funding, but business models and the distribution. So we're talking about complex systems. I've got it back, where potentially the data sources that are required are fragmented, distributed, held by different people. Maybe the people are participating for different reasons. Mm-hmm. Do you see the need for some kind of coordinating either national or supranational body to try and ensure that those data sources are made available and that the different parties can collaborate effectively?
Yeah, so I think there's a great need for that. I think within the climate modeling fraternity, there has been quite a bit of harmonization over the last couple of years, but it's great to see the weather and the climate community moving closer together. I think there is greater discussion of that. I think over time, there is a pre-competitive space for, let's say, the insurance sector or the asset management sector to start sharing standards of data, right? Because I think then we can start comparing different assets in different parts of the world, different impacts in different parts of the world, if everybody had a common approach to at least the data. So if there is a co-op structure, is some sort of data depository structure, we'd be very open to that. And that's part of what we wrote about in terms of the ethics around climate data. There's a certain pool of it that needs to be put together in the public trust almost. And this becomes, again, more important given that the public are ultimately the sort of backers of last resort, as we've just seen with COVID. So I think you're going to see the same type of behavior within the climate risk world as well. Governments will ultimately be the last people to bail folks out. So getting policymakers to understand how to use climate intelligence, how to use different data in a pre-competitive space, I think would be most welcome.
Jack, are you seeing any signs of this coordination happening?
So we definitely need to make it easier to access a whole bunch of energy and climate data, although a lot of that's coming on stream already. Part of the answer there is quite likely to be more open standards. So rather than sort of trying to regulate it too much, defining sane open standards and conventions and sort of, as Gavin Starks at Icebreaker One would say, sort of preemptive licenses. So today, one of the big challenges of sharing data is that even if the board of a company say, yeah, cool, we're happy to give you data, just sign it off with our lawyer, it then takes another 1.5 years to go through the details with the lawyer. Whereas if there was just a standard license that everyone was familiar with, then that would take away all of that pain. So, for example, today when you go and read Wikipedia, you are, entirely comfortable that's under a Creative Commons license. Is that under yeah, I think it is. And people know what that means, and that works well. I think, that's one of the big parts of this.
Thank you. I'm being told we have 2 minutes left, so a quick fire final question for both of you to answer. What is your advice? What's the best thing to do for a machine learning specialist that wants to move into working on impactful problems in climate change?
So I think there are a few bodies in the world that are looking at climate well and have created research residency programs. I think that's one avenue in. So there's a Google program, we have a program, DeepMind have a program. I think large companies that have got structured research programs, I would say try it. This is a fairly complex domain. Try and get residencies where you can. And I think there's a few more collaborative platforms now that have come up. There was a very interesting research paper which I think was called Machine Learning and Climate Action, Jack.
Is it the Tackling Climate Change with Machine Learning paper?
Yeah, that's a good entry point, because that then breaks out all the climate problems by different domains: energy domain, waste disposal, agriculture. That's a good entry point to read for anyone to read, and just jump onto the forums as much as possible. Obviously, there's companies like Jack's company, my company, other firms that are opening up, just have open conversations. But I think the space is opening up for a lot more ML. There's a lot of interest in ML and climate all of a sudden in the last couple of years. Certainly wasn't there 5 or 6 years ago.
Thank you. Anything to add to that, Jack?
So definitely agree. Go and check out that paper. But also, I suppose my one thing in the last 20 seconds is dive into the domain. So go and do internships at your local electricity grid system operator or other energy company. I think in many ways, the hardest bit to wrap your head around in these problems is the domain. These domains are enormously complicated, and there's just and a lot of it isn't really written down. You just need to go and spend as much time as you can with people in a domain and really soak up the challenges that they face.
Thank you. We're going to wrap up now and move to questions. There wasn't nearly enough time in this session to get into everything that we could have talked with Jack and Iggy about. So do join us for those. I wanted to bring Jack and Iggy here because they have done something concrete and real using machine learning to try and be impactful in this space. So I thank them very much for sharing what they're doing.
Thank you very much, Libby, Iggy, and Jack. That was an absolutely fascinating discussion. And as Libby said, they're going to be moving into the Q&A section at 3 o'clock, and it'll run until 3:30. So any questions that have already been submitted through Slido will get fed to Libby to put to Jack and Iggy. But of course, please do join the session and add any of your questions as well that you've not yet had the chance to ask. So that'll be kicking off at 3 o'clock. So do go and join that. And then later on this stage, we've actually got a break. The next session is not until 5 o'clock. That's going to be on making workplaces safer, tech to see us through to a vaccine. Really exciting things coming up later on this evening. Thank you very much.
Want access to more CogX videos? Subscribe now for free at cogx.co.